Alright, next, let's take a look at some of the more critical engine sensors. Now, there's plenty of engine sensors that we could add to our engine. Things like oil pressure, fuel pressure, and exhaust gas temperature sensors. But we're going to take a look at the sensors that we typically need to get the engine to run. The first sensor we'll look at is the MAP sensor, or the Manifold Absolute Pressure Sensor. This sensor is used to measure the pressure in the intake manifold and can be found mounted directly on the intake manifold, remotely mounted and connected with a vacuum hose, or mounted inside your engine management system, again connected to the intake manifold with a vacuum hose. MAP sensors are available in a wide range of pressure ratings. Typically, a naturally aspirated engine would use a 1 bar MAP sensor, whereas a forced induction application may use a MAP sensor capable of measuring up to 7 bar of pressure. The next sensor we need to take a look at is the throttle position sensor, mounted on the side of the throttle body itself. The throttle position sensor is used to measure the throttle blade angle and is referred to as throttle position or TPS. The TPS value is used to add extra fuel upon rapid throttle opening, enabling the idle control strategy and disabling the injectors under high RPM zero throttle conditions. This is also known as deceleration cut. Mounted between the air filter and the throttle body, we sometimes find the mass airflow meter. It measures the mass of air going through the engine. The engine management system will display this value as grams of air per second. If you plan on doing any reflashing of factory ECUs, you'll certainly need to know about this sensor, as it's one of the more common sensors used in factory cars. All of the air entering the engine must be plumbed to pass through this sensor in order to accurately determine the mass of air going into the engine. It's important to note that not all engines are fitted with a MAP sensor and airflow meter. You could have one or the other, or both. The next thing that we need to look at is the coolant temperature sensor. To accurately characterise the engine, we need to know the coolant temperature and air intake temperature. The coolant temperature sensors fitted in the engine's cooling system in a position that best represents the engine's operating temperature. The coolant temperature sensor is used to make fuel and ignition adjustments, idle speed adjustments, as well as enable a range of engine management functions. The air temperature sensor needs to be fitted into the intake tract in a place where it will not be affected by heat soak and gets the best representation of the intake air temperature. This air temperature is used along with the manifold pressure to determine the density or the weight of the air the engine is consuming. We can also map the fuel and ignition targets based on the inlet air temperature. The last of the critical sensors is the oxygen sensor. As the name suggests, the oxygen sensor measures the remaining oxygen in the exhaust. This sensor value is displayed as an air to fuel ratio. Now, there are two types of oxygen sensors described as a narrowband and a wideband sensor. A narrowband oxygen sensor has up to 4 wires and measures an air fuel ratio of 14.6 to 14.8 to 1. A wideband oxygen sensor has 5 wires and accurately measures an air fuel ratio of around 10 to 1 to 20 to 1. The oxygen sensor is mounted in the exhaust system approximately 18 to 24 inches from the header collector or the rear housing of the turbocharger. It should be mounted in the higher side of the exhaust system to avoid water or condensation damaging the sensor.